All right, so yeah, so the next lesson here is problems involving conditional probability. Okay, so the last lesson was yeah, a bit of an introduction to conditional probability. So now we're actually going to kind of get into a little bit more detail. And for this lesson, we're actually going to be using a formula. Okay, so so this formula that we got here, I'm going to explain what the notation is. So this probability of A with a slash B, it's the probability of A happening given B. Okay, so these are both events. All right, so if we know that event B has happened, we're going to find the probability of A. All right, and this is equal to the probability of, actually, I'm just going to end up writing the same thing over here. So probability of A and B happening divided by the probability of B. Okay, so so this formula is like the it's actually got a special name to it. Not that it really matters to you guys, but it's called Bayes' theorem, and it's a very kind of it's one of the more important formulas in terms of probability in general. All right, but anyways, the best way to actually see how this thing works is through examples. All right, so I got two of them for you in this lesson. All right, so. Okay, so let's just get right into that first one here. So Ryan is asked to choose a number between 10 and 40, inclusive. All right, so inclusive means you're including 10 and you're including 40. That is divisible by 4. Okay, so he picks a number that's divisible by 4, and we want to determine the probability that the number he chooses is also divisible by 3. Okay, and then there's 3 different ways they want us to do it. So using logic, a Venn diagram, and the conditional probability formula. Okay, so these are 3 different methods to get the same answer. Okay, so so I'm going to go through each one, but what we're going to end up doing with the next example after this one is we're going to be using the conditional probability formula, which is right here, which is this one. All right, so anyways, the first one here, let's go with logic. Logic. Okay, so when it comes to logic, if we were to answer this question, all right, we want to know the probability of getting a number divisible by 3. Right, given, and he's already chosen a number that's divisible by 4. Okay, so this divisible by 4 it's kind of like it's already happened. Okay, so this is the condition. All right, so logically, the way that we can figure this one out is what we can do is we can actually list off all the numbers that are divisible by 4 between 10 and 40. So let's say, yeah, so divisible by 4. I'm just going to list them off. So the first number there would be 12, right? So 12, then 16, 20, 24, 28, 32, 36, and also 40. Okay, so we're including, when it says inclusive, it means it's including these 2 numbers here. Okay. So if he's already been asked to choose one of these numbers. Okay, so there are 8 in total. Okay, so these are 8 numbers. All right, if we count up the number here. So there's 8 total there. And then we want to find the probability that it's divisible by 3. Okay, so he has chosen one of these numbers. What is the probability that he's actually going to find one that's divisible by 3? Okay, so of these numbers here, the ones that are divisible by 3 are 12, the 24, and 36. Okay, so therefore, to answer this question, just using logic, 3, so these 3 out of the 8 would be this probability. Okay, so I'm just going to write probability of being divisible by 3 given it's divisible by 4. And between those numbers is going to be 3 out of 8. Okay. All right, because there's 3 of these numbers. 3 numbers out of the 8 are divisible by 3 as well. Okay, so this is just using logic to find this probability. Okay, so again, he was asked to choose one of these 4, and we just want to know what the probability, given that he's chosen one of these 4, what's the probability that it's also divisible by 3? Well, 3 of these 8 are divisible by 3 as well. All right, hopefully that makes sense. Now the next method is to use a Venn diagram. All right, so if I wanted to use a Venn diagram, what you would do is you would draw these 2 rings. All right, and what I'm going to do is just kind of list off numbers that are divisible by, divisible by 4, and also divisible by 3 between 10 and 40. All right, so actually, you know what? I may not have made enough room here, so let me just draw this thing a little bit bigger. All right, so let's try that again. Yeah, because I got a feeling I'm going to need a lot of room here. All right, so divisible by 4, divisible by 3. Okay, so I'm just using those 2 numbers there as labels. Okay, so divisible by 4, divisible by 3. Okay, so if we start off here, let's start with 12. Now 12 is also divisible by 3, so it kind of overlaps, right? What would be the next one here? 4 and then 16, 20, 24 is divisible by 3 as well. Would also have 28, 32, 36, and 40. Okay. Now, if I actually want to complete this Venn diagram, over here in this side over here, I'm just going to write out the ones that are also divisible by 3. So it would be 12 and then 15, 18, 21, 24 is right there, 27, 30, 33, 36, and 39. All right, so this would be kind of like the complete Venn diagram. All right, now you can see here visually that 3 of these are in both rings, right? So 3 out of the, so this again, this probability of being divisible by 3 given it's divisible by 4. Okay, so you can see that 3 of these, 12, 24, and 36, so 3 of them out of the 8 that are in this whole ring of 4 are divisible by 3. Okay, so this is the way that you would do it with a Venn diagram. All right. Now the third method that they'd like you to use is by using the formula. Okay, so I'm gonna again write up the formula that was at the top there. So probability of A given B is equal to the probability of A and B divided by the probability of B. All right, so in terms of this problem, this is the probability of being divisible by 3, given that we know it's divisible by 4. Okay, because again, he's asked to choose a number that's divisible by 4. So this is equal to the probability of being divisible by 3 and 4 over the probability of being divisible by 4. All right, so if we actually, you know what, I'm going to kind of use this Venn diagram here just to show how to get these probabilities. Okay, I just don't want my cursor getting messed up here, so just one sec here. All right, so what's the probability of, actually I don't need the P there, probability of being divisible by 3 and 4. Okay, so so what we can take into account is that we have 3 numbers here, so 3 out of the 3 out of the, so between, okay, so between the 10 and 40, there are actually between between 10 and 40, there are actually 31 numbers. Okay, the reason there's 31 is because, or sorry, that's inclusive. Okay, so the reason there's 31 is because we're counting the 10 as well as the 40. Okay, so if you go 40 minus 10, that's 30, but we're adding one more, okay, because we're actually including both of these numbers. Okay, so in other words, 3 out of the 31 numbers are divisible by 3 and 4. Okay, now the number that's divisible, the probability of getting a number that's divisible by 4 would be, again, 1, 2, 3, 4, 5, 6, 7, 8. So 8 of the numbers are divisible by 4. So 8 out of 31. Okay, so if you, if you remember your fraction rules, and I'm going to have to actually drag this down to the next here, next space here. This is the same as 3 out of 31 divided by 8 out of 31, which is equal to 3 out of 31 times the reciprocal. So that's 31 over 8. And what happens is these two 31s cancel, and you're left with 3 out of 8. Okay, so this is how it would happen with the formula. Okay, so what you notice is that we get 3 out of 8 again. And we had 3 out of 8 with a Venn diagram, and we also get 3 out of 8 just by logic. All right, so we get the same answer 3 times. Now, these are just 3 different methods of getting the same answer. Now, hopefully, these first 2 made sense. And the reason, and the third one here is using that formula. Okay, so again, these 2 numbers, 3 out of 31, 8 out of 31. We're going to be actually using this formula a lot for the rest of these questions, right? And for the majority of the questions on the worksheet for practice. Okay? But I guess this first example here, just to kind of tie in the other 2 methods. All right. All right. So this is, again, this Bayes theorem is the formula that we're going to be using quite often. All right. So we're going to use that actually to answer this next question. And and I'll be honest with you guys that traditionally this conditional probability is one of the more difficult concepts in this course. All right. So yeah, so you may have to rewatch this lesson a few times, and it might take you some time to do the practice question on the worksheet. But through practice, you should be able to get it. All right. But initially, yes, it can be quite confusing. All right, so let's go into example 2. So a factory uses 2 machines to produce small batteries for electronics. Machine A produces 65% of the batteries, machine B produces 35%. Okay, so between the 2 machines, that's 100% of the batteries. Each machine produces some defective batteries. Right? So machine A produces 10% defective, and machine B produces 14% of defective batteries. All right, so what is the probability that a battery is defective? Okay, so there's a lot of numbers kind of being floated around here. So what we actually got to do with these types of questions is we got to actually make a tree diagram, or tree diagram, just kind of like what we did in the last lesson. All right, so first thing we want to do is we're going to split it up. All the chips are either going to come from machine A or machine B. So the probability that a battery comes from machine A is 65%. So I'm going to write that as a decimal. So 0.65, it goes from machine A. From machine B, it's going to be 0.35. Okay, so again, 65% of the chips come from machine A, 35% of the chips come from machine B. Now we want to see whether they're defective or not. Okay, so for machine A, 10% are defective. Okay, so I'm just going to put 10% here are defective, whereas 90% therefore are, we're going to put defective, I'll just write okay. All right. Now, if for machine B, we can see 14% are defective, so 0.14 are defective, which means the other 86% are okay. All right, so it's either going to be defective or okay, defective or okay. Okay, so this is just kind of breaking down the different branches kind of like what we did before. All right. So now what we do is we can calculate the probabilities of a chip coming from machine A and being defective. What we do there is we actually multiply the probabilities together. Okay, so for instance, 0.65, I'm gonna multiply it with 0.10, and we get 0.065. Okay, so this is 6.5%. So 6.5% of the time, the chip that you get will come from machine A and be defective. All right. Now, if we do the same thing, multiply here. So when I multiply 0.65 with 0.9, this is the probability that a battery, I keep saying chip, sorry, but batteries. A battery comes from machine A and is okay. All right, so let's take out the calculator again. So 0.65 multiplied by 0.9. Is that right? Yeah, so 0.585. Okay, so 58.5% of the time, a battery will come from machine A and be okay. All right, so that's what this branch represents. All right, next up, 0.35 times 0.14. Okay, so that's 0.049. All right, so 4.9% of the time you'll get a battery that comes from machine B and is defective. And then finally, we'll take 0.35 and multiply it by 0.86. You get 0.301. Okay, so in other words, 30.1% of the time, a chip will come from machine B and be okay. Okay. Now, what you'll notice is that, and this is kind of an aside though, but it's that when we add all these four probabilities together, this is going to equal, it should equal 1.0%, right? So, or 1.0%, sorry, 100%, right? So I'll just do that quickly. So 0.65 plus 0.585 plus 0.049 plus 0.301 equals 1, all right? So this is equal to 100%, because that makes sense, right? Because these are the only four possibilities that a chip could happen, right? Or what could happen to a chip, right? It could come from either machine A, I keep saying chip, sorry, I mean battery. It can come from machine A, or it comes from machine B. But if it comes from machine A, it could be defective, it could be okay. It could come from machine B, it could be defective, it could be okay. Right, so these are the four possibilities. When we add up these up, that's 100% of the chips. All right, so now to answer the question, we want to find out what is the probability that a chip is defective. All right, so the chip is going to be defective when it comes from A and is defective. It comes from B and also is defective. So it's these two branches right here. All right, so to answer this question, the probability of a defective chip this is going to equal 0.065 plus 0.049. Okay, so this is going to equal, if I add that together, please bear with me, 114, sorry. Yes. All right, so in other words, 11.4% of the time, you'll get a defective chip, okay? Because that's these two branches right here, okay? Defective and defective. So it's either going to come from machine A or machine B. You'll be defective. All right. Okay, now for part B, it's asking what is the probability that a battery came from machine A if it is defective. All right, so notice that the if statement, right? So this, if it is defective, we know that it is defective. So this is the kind of like the given part. And we want to find the probability that it came from machine A. This is the probability that we're trying to find. All right, so in terms of notation, We want the probability that it came from machine A, given that it is defective. Okay, so to answer this question, we need to use the formula, the Bayes theorem formula, which was the one at the very beginning. All right, so excuse me, the Bayes theorem is that probability A given B. All right, maybe I'll write it up here. Probability of A given B is the probability of A and B divided by the probability of B. Okay, so if we were to interpret that here, probability that it comes from machine A, given that it's defective, is the probability of machine A and defective divided by the probability of a defective chip. Okay. So the probability of coming from machine A and being defective, what I'm going to do here is just scroll up. So this is A. This is being defective. So this is the probability here, 0.065. Okay. That's 0.065 divided by. Now the probability of being defective, we actually answered that in part A here. So in other words, it was these two branches when we add them together. Okay, so which was 11.4%. Now just to illustrate that, yeah, it is these two here. I'm just going to write it as a sum again. So 0.065 plus 0.049. Now, what you'll also notice is that when we're using this Bayes theorem, this number here, this probability, so A and B, will actually show up in one of these when you're adding up the total defective chips. So there will be like a repeat. You'll always find this pattern, right, where the probability of A and B is going to show up here when you add the two. All right. So this is 0.065 divided by, and if I add that up, that was 0.114. So that's 6. And now that I've got those two here, let's just punch that in. So 0.065 divided by 0.114 equals 0.57. What was that? 57. Let's just leave it at 0.57. All right. So 57% of the time. Okay. So if you know a chip is defective, 57.5% of the time it'll come from machine A. All right. Cool. So yeah. So this I'm not gonna lie to you guys. This is one of the more trickier concepts when it comes to probabilities, or this course in general. Okay. So yeah. So don't feel too discouraged if you're a bit confused right now. Through practice with a worksheet, which I'll pull up right now. Or actually, yeah. So this is the practice worksheet. So your practice for today, I split this up into 2 lessons actually. So the practice for this lesson would be numbers 1 through 8. Okay. And then numbers 9 through 18 I'll cover in the next lesson. Okay. Yeah, so those actually, to be honest, these numbers 9 through 18 is like something totally different. It has nothing to do with conditional probability, but they decided to put this in on the same worksheet. All right. So yeah, so for practice, again, numbers 1 through 8. I think I got that written down. Excuse me, numbers 1 through 8 on the worksheet. All right, cool, guys. So that's the lesson. Talk to you guys later.